In this video, we will learn about contact and non-contact forces. So from the viewpoint of application of force, force may be classified into two categories. The first category is of contact forces and the second category is of non-contact forces. So let us start by contact forces first. We will take some examples to understand this better. So the first example is when you push or pull a door, you apply some force on that door and there is some physical contact between that handle of the door and your hand. Second example is when you kick a ball. You apply the force on that ball by your foot and there is physical contact between your foot and that ball. Or we can say not just physical contact, we can also have some connector like a horse which is pulling a cart, and a horse, it is not directly connected to the cart, but there are ropes which are connecting the horse to the cart. Or you can say a railway engine which is pulling a stationary train. So these are the examples in which the force acts on the two objects which are in physical contact with each other, and such forces are called contact forces. So once again, what are contact forces? Contact force is a force which acts when objects are in actual physical contact with each other or are connected through some connector. Now let us explore some examples of contact forces. The first example is frictional force. So you must have experienced some resistance when you try to apply some force, be it a push or a pull, on an object which is kept in contact with some other surface. So that resistance is caused by frictional force, and that frictional force acts tangential to the two surfaces which are in contact and in a direction opposite to the direction of external force, so as to oppose the sliding motion. The frictional force opposes the sliding motion which is caused by the external force. So in this example, you can see force is being applied in the rightward direction and a frictional force is opposing the motion of that object which is caused by that external force. So the frictional force is a contact force and it acts only when there is an actual relative motion or an impending motion between the two objects or surfaces. Frictional force opposes or tends to oppose this relative motion. So for example, there is a block which is kept and on a rough surface. Surface is rough and we apply some force on this object. So this object has a tendency to move in the rightward direction because of that external force. So to oppose this motion, frictional force will be applied and will oppose this tendency of motion. So frictional force will be applied in this direction. So that is what is written here. Similarly, if a wheel rolls over a surface, a frictional force starts acting so as to oppose the rolling motion of the wheel. Force is acting at the point of contact of rolling wheel and the surface over which it rolls. This must be clear. That is frictional force. The next type of contact force which we will be going to study is normal reaction force. So we have considered an object which is kept at rest on a horizontal surface. We know that gravity is exerting a force on that object which is in vertically downward direction and which is equal to the weight of that object. However, that object does not move. Why so? It does not move because the surface exerts an equal and opposite force on that object in the vertically upward direction. This force exerted by a surface on an object placed over it is called normal reaction force. This normal reaction force is a contact force and always acts normal to the surface. Normal reaction force is generally represented by the symbol N. You can see in the diagram, normal reaction force is being applied by the surface which is normal to the surface. S forces W, which is the weight of that object, and N, which is normal reaction force, are equal in magnitude but mutually opposite in directions. The net force acting on the object is zero, and this is why the object remains at rest. Another type of contact force that we will be going to study is tension force in a string. To understand this, we have taken an object and it is tied to a string, and the other end of the string is tied to a rigid support of a ceiling, and that object is suspended. We know that the object will be at rest and there will be a weight that will be pulling the object downwards, and the object is at rest. So this is due to a tension force which is provided by the string is pulling it upwards, and which is equal to the weight of an object. So the string pulls the object in vertically upward direction, and that force developed in the string is called tension force, and that force is denoted by the symbol P. An equilibrium state, the tension T in the string is equal to the weight of an object. Another important point to prove the existence of tension force is that if we cut the string from slightly above the contact points, there will be a jerk in the string in upward direction. This will prove the existence of the tension force acting in the upward direction. I hope it is clear to you. Thank you.